And so with that as your only selection group, I did not have the ability to randomly lay out tiles and then evolve what is around them until it's filled in. So it's sort of more genetic in a way, or generative. It made more sense to approach it linearly, which is column by column, row by row. Otherwise, I would find myself in a situation where I would have laid out 3 tiles that had no adjacent tile that was allowed, and then I would be stuck.
So the other thing that I see here, right, is that this is because you've got a subset of tiles that all fit together. Mm-hmm. But if you had just one tile that was fairly seamless, that you could just run through and just fill in the background with that.
You could, but it would have to also that tile would have to match with any other tile in your set. And this set of tiles doesn't have that kind of flow. I mean, there's not like one base tile that matches with all the other tiles. It's got multiple tiles that can seamlessly merge into other tiles, but not any other tile.
Yeah, it's meant to
so you can
create
define
complex
additional rules of creating like this one genome and it must be covered with another genome, like for example jungle to grass transition, right? You can't transform jungle to dirt. First you have to go through grass like that, right?
Right, yeah, absolutely you can. That's what the let me go back to the document here. That's what the BB segment of this is. It allows you to change from one group type to another group type. I'm not transitioning from group type to group type. I'm staying within the same group type. Sand 3, grass 2, whatever. But if I had the time, it's all a question of time. I didn't want to invest too much time and effort in this because the ground was not a driving factor as much as some of the other elements, which is like pickups and movement and things like that. And so I didn't think it was worth the time to do additional labor selecting a very complicated algorithm that when I finished it, nobody would be able to read anyways. I mean, the one I've already got is getting pretty hard for folks to read. The thing is I could make it better, but then I had to spend more time on it. It's always a question of time. So I didn't think it was worth the investment to go beyond basic transitions to new tile types within the same group. So it makes a somewhat boring background, which is unfortunate, but it's an order of magnitude more work. And for me to make it legible for people in the audience so they could actually understand what this code is doing. Not doing this a whole lot, I decided it wasn't worth it.
All right, yeah, I mean, obviously there's a bunch of different ways this could be done.
So let me just say, I want to get off this topic because, again, it's only 260 lines of code. It looks very complicated, but if you just walk through it, take your time, I think people will be able to pull this apart and kind of understand what's going on. I've also left some comments in here so you can uncomment some of these things when you run it and see what comes out in the console as far as the kind of logic it uses to select things. Total tiles. This here will print out the group that was selected. So the subgroup is basically, once it gets through all of the code above, it will have a table that's got 1 or 2 or 3 different tiles that it's allowed to choose from. And then I randomly choose one of those, and that's the tile I use. So every time I go through, it's very expensive, but because it's desktop, we don't care so much, and it's a one-time operation. I go through all these selections and create a table that only has a certain subset of all the tiles within the group that I'm allowed to lay out for this particular one. So it's very wasteful, but it's algorithmically straightforward so that people should be able to follow it. That's the best I can say.
Gotcha. Human readable.
I'm trying to make it, I tried to make it as human readable as possible so that people could grok this. People could fit it in their head what's going on without elaborate rules that say, anyways, I'm not going to go there. So what do we got here? I wanted to show you next was the enemy logic and how that works. Last week we talked about that. So that should be a pretty quick thing. And then we might have time to get into picking up the gems and going on to the next level. So last week, let me find it, we were looking at the enemy manager. And if we go down to the bottom, a little bit bigger, I found that this editor, although I like working with it, is not as good for presenting code on the show. However, I'm in it, so I'm going to stick with it. Well, you know, it's a little bit harder. The other one, I had more screen room where I could do split screen and still show it to you.
Mm-hmm.
Where are you? Okay, so last week we had just two variants. We had move to player, and we had another one we called move to player 2. In this week, I have changed the name of the second one to call it chase player. So what last week was called move to player 2 is now called chase player. Chase player is a piece of code that will take a few steps, look where the player is, pause, or stop the animation, and then redirect the player, so it's always chasing. So the red zombies chase, the green zombies simply move from one location to the next, and then they chase. They don't chase as frequently, basically. It's like move player is see the player, move all the way to where the player was, even if the player moves, you just completely ignore it. And then when you get there, look where the player is and move to where the player is now. Chase player is move in the direction of the player, wait a little bit, check to see if the player has moved, move in that direction, move to the new place. It's continually cycling every half second until you catch the player. And then the new one for this week is called chase and shoot player. And we won't go through all the code, but it's quite similar to chase, except that it has phases. Initially, you are chasing, and if you are chasing, you first set your mode to pausing. So that says the next time I come into this algorithm, I'll be pausing. But right now, I am chasing, and I calculate the distance to the player and the direction and all that, just like we did last week. And then if I'm close enough, I will just continue on. But if I'm not close, and it's going to take me more than 1.1 seconds to get to the player, I will perform with delay a timer. In other words, I will call a timer in 1 second, and that will execute the same function we're in. This is the same thing we did last week. And then I will set my angle, play the right animation, and start moving. So I'm chasing, set the mode for the next time, do the calculations to figure out how long it's going to take me to get to the player. If it's going to take a long time, schedule another iteration of this loop. If not, simply fall through there, set the angle, start walking, move to the player. Now the next time we come in 1 second, we'll be in the pausing mode. So the first thing we do is we cancel the transition from last time because we're using transitions to move. Then we set the next mode to be shooting, and we have already calculated our angle, etc. above, and we set the animation to paused, and this is where the skeleton will simply stand there, and then we wait 2 seconds. So when you're playing a game and you see a skeleton moving, you don't worry about it. You don't let him walk into you, but you don't care. The moment you see a skeleton pause, that's when you need to worry. As soon as they pause, you know you got 2 seconds until they shoot at you. Now, people playing the game will go, oh, I got 2 seconds. People writing the game will say, yes, I got 2 seconds. But when you see it as a player, this is one of those discoverability things. Initially, people are like, what's going on? And then suddenly the skeleton will shoot at you, and then you get the hint. Ah, he walks, he pauses, he shoots. So if I see a pause, I need to start paying attention to where that is and get out of the way because he's going to shoot at me. So 2 seconds later, we'll come back into this same piece of code, and we will not be in chasing mode. We will not be in pausing mode. We'll be in some other mode, which is shooting. So that'll be our default case. first thing we do is we set the next mode to be chasing, so the next time we come back in, he'll start walking again. But then we get this angle that we calculated above, we play the shooting animation quickly, and we call a method called fire arrow, which I have written this week. It's the very same code that we had for the player last week, except it produces an arrow that has a new body on it that will collide with the player horizontally.